Today we're going to be talking about section 1.6, which is on solving linear inequalities. And when we talk about a linear inequality, and this we're going to be talking about them in one variable today, it's an inequality that can be written in one of the following forms, where a and b are real numbers and a is not equal to 0. Notice that's like slope-intercept form, except for we don't have the y variable, but ax plus b, and then we either have less than 0, less than or equal to, greater than or equal to. So it's one of the 4 inequality signs that we use most often. And just like in an equation, a solution is a value when substituted for the variable results in a true statement. So you plug the number into the inequality. If it makes it a true statement, it's a solution. If it doesn't, it's not a solution. So if we plug a variable in, we get 3 is less than 7. That's true. So 3 would have been a solution to that problem. If we plug in and makes it a false statement, then obviously it's not. And the graph of an inequality in one variable consists of all points on the number line that represent the solution. And we've graphed these a lot before. So let's start with graphing the following inequality. And we have x is greater than negative 3. And so we're going to put the number negative 3 on our number line, and you can label these however you want. However, the intervals between each one, so notice I went every 2 and I put a number there, so I have my integers. And then we have a circle on where negative 3 is, and notice that that one is just greater than, so greater than numbers are always to my left, so it is answers there. Now, if we recall, when we were graphing these before, this is just greater than, it's not equal to, so we're going to have an open circle there. In example B, this one is equal to, so if we put 0, 1, 2, negative 1, negative 2, and it's going to be less than, which goes to the left, and I fill this one in because now 0 is one of the solutions, because 0 is less than or equal to 0. Now, a compound inequality consists of 2 simple inequalities joined by either and or or. And means that both of them have to occur at the same time, and or means either one or the other. They both can occur, but at least one of them. So what we're going to do in example 2 is we're going to graph a couple of these. And we want to make sure that we get all of our numbers on our number line. And notice we have this part of the statement, which says negative 2 is less than or equal to x. And then and less than 3. So negative 2 is less than or equal to x, which is less than 3. That's an and statement. They're both in there together. So I'm going to take the left part, which is the part that I underlined, and I'm going to read it the other way, just because I like to graph them from that. So it says x is really greater than or equal to negative 2. So that means I'm going to have an arrow that goes like this, and it's filled in. Then if we look at the right-hand side, and that's this part of it, that says x is less than 3. And so this goes this way. Now, where do they both occur at the same time? Well, that's everywhere in between them, because it's an and statement, so it has to be true for all of them. So everything in that shaded area is a solution. Now notice we have a filled in circle at negative 2, which means that one is a solution. We have an open circle at 3, so that one is not a solution in this case. If we jump over to B, B is an or statement. And these are super easy to graph because essentially you just have 2 problems. We're going to take the left side, x is less than negative 1. Open circle goes this way. We're going to take the right side, x is greater than or equal to 1. Filled in circle goes this way. And our solution in this case is anything that occurs in either of them. So it goes in both directions. So what I would like you to do right now is go ahead and jump down to the guided practice questions. You can go ahead and do those 4 and then hit, or so you can pause the video and then hit play when you're ready to move on. And there are the solutions for the guided practice questions. Notice anytime that we have an compound inequality in examples 3 and 4, we must show where our solutions are. And I did that with blue in this case. So those are the solutions. So the next thing we're going to talk about are equivalent inequalities. And inequalities have the same solution as its original inequality. And this is the same thing that we talked about the other day with our equations. So in example 3, we're going to solve an inequality with variables on one side. So it says you have budgeted $66 a month to spend on yoga classes. Your yoga studio charges a membership of $22 per month plus $5.50 per every class you attend. Describe the possible number of classes you can attend each month. So you have to pay $22 per month, no matter what, whether you go to 0 classes or 100 classes. And then you're going to pay $5.50 per class. And it says you have budgeted $66 a month, which means you can spend a total of $66. Can you spend more than that? No. Can you spend less than that? Yeah, just because you've budgeted doesn't mean you have to spend it all. So there is where we get our inequality. It has to be either less than or equal to the $66. Okay, and as we go through here now, we're going to solve this inequality. We're going to solve this inequality exactly like it was an equation. There'll be one exception one we'll talk about later, but essentially it's the same thing. So we're going to subtract the 22. And we're going to get 5.5c is less than or equal to 44. And then we're going to divide. And so we get c is less than or equal to 8. Okay. So that tells us that we can attend at most 8 classes. And the reason is we know that c has to be less than or equal to 8, okay, which c represents our classes. And so therefore, we've solved this and we can go to 8 classes. Now, if we plug that back in, 8 classes would give us exactly $66. So that is the maximum number of classes that we can attend. Example 4 now says we're going to solve an inequality with variables on both sides. And again, we did this with our equations last week. So we're going to do the same thing. We have to get our variables on the same side. Now, there's one of 2 ways you can look at this. And with inequalities, it makes a little bit of difference. You can either get your variables always to the left side, which is what some people like to do, or you can always get your variables to the positive side. Now, personally, I like to have my variables on the left side because it's just easier for me to graph that way. So I'm going to move these. So I'm going to subtract 6x to get it over here. So I'm going to have negative 2x plus 3 is less than or equal to negative 5. Now I'm going to subtract the 5. So I'm going to have negative 2x is less than or equal to negative 8. And this is the difference between an equation and inequality. I'm going to divide by negative 2. Anytime you multiply or divide an inequality by a negative number, you must switch that inequality sign around. So I'm going to end up with x is now it's going to be greater than equal to, because we divided by a negative 2, 4. Okay, so x is greater than or equal to 4. There is our inequality, and we want to graph it. and there's your solution. Now, you can always check to make sure that it works. Plug one in. So let's say I take the number 6, and I plug it in. Well, that's going to be 24 plus 3 is 27, and 6 and 6 is 36, minus 5 is 31. Is 27 less than or equal to 31? Yeah, it is. It's a true statement. Therefore, 6 is a solution. If we'd plug a number in on the left side, like 2, we'd find that it is not a true statement, so the solution, it would not be a solution. So go ahead and do the guided practice questions 5 through 8. You don't have to do all of them if you don't want to. Do a couple of them, but go ahead and pause video and you can hit play when you're ready to move on. And there are the solutions to the guided practice questions 5 through 8. Jumping down to example 5, it's going to say solve an and compound inequality. So we're going to solve this, and then we're going to graph it. Now notice in this case, we now have 3 parts of our inequality. The left side, the middle, and the right side. So again, our goal is always to get the x by itself. So what we're going to need to do is subtract the 5. We want to get rid of that plus 5. So we subtract it. But we have to do it to all 3 parts of the inequality now. So we're going to subtract the 5 from there. And so we're going to end up with negative 15 is less than 3x, which is less than or equal to 3. And now I have 3 times x, so we have to get rid of the 3. So we're going to divide by 3. So now it's going to be negative 5 is less than x, which is less than or equal to 1. So there is our compound inequality, and it's an and statement. Anytime that you see one that looks like this, it's going to be an and statement. The only way it's going to be an or if it says or inside of it. So we're going to put our numbers up here. We're going to need those. All right. So x is greater than negative 5. X is less than or equal to 1. Which means our solution is everything in that black part that's shaded. Number 6 now is a compound inequality that is going to be an or statement. And notice it has an or. And essentially, we are breaking this into 2 parts. We're going to solve the left side, solve the right side, and then we're done. So it's going to be 2x is less than or equal to negative 6. We added 1. Now we have to divide by 2. Again, we're solving for the x. So x is less than or equal to negative 3. Or, now here we're subtracting the 3. Divide by 4. So those are our 2 statements. Either x is less than or equal to negative 3, or x is greater than or equal to 1. Now notice they can't both be true at the same time, but if either of those 2 statements is true, then we know that it is a solution. So I know that either it's less than or equal to, it's less than or equal to negative 3, or it's going to be greater than or equal to 1. And once again, our solutions are on the outsides. So everything that goes out from there. Now we're going to jump down to example 7, and it says we're going to write and use a compound inequality. It says in Illinois, the lowest temperature on record is negative 36 degrees Fahrenheit in January 1999 in Congerville, while the highest temperature on record is 117 degrees Fahrenheit in July, which was in East St. Louis. Write the range of temperatures as an inequality. So if we're looking at those, well, we know the coldest it's going to get is 36. The hottest it's going to get is 117. And we're going to call T the temperatures. So we're going to write a compound inequality. We know that the temperatures must be between in there. So it's got to be either greater than or equal to negative 36 or less than or equal to 117. And so here is our answer. And that's in degrees Fahrenheit because that's what the temperature asks us for. Now, the next part of the question says, then write the inequality given the temperature degree in, or the temperature range in degrees Celsius. So we need to know what the conversion is from Fahrenheit to Celsius. So what we're going to do now is convert this into degrees Celsius because that's what they want. And so we need to find that conversion. And so we're going to write that in here. So we're going to go negative 36 is less than or equal to it. And if we look it up, the conversion is going to be 9/5 C plus 32 equals F. And then so then we're going to have 117. So C is now going to write Celsius. So once we convert all of this, it'll be in degrees Celsius. So we're going to subtract 32 from all three sides. So that's going to give us negative 68 is less than equal to 9/5 C, which is less than or equal to, if we subtract the 32, it's going to give us 85. And now we're going to multiply by the reciprocal. We have 9/5, so we're going to multiply by 5/9. And so if we do that, we're going to get approximately negative 37.8 for the Celsius at the low end. And if we take the 85 times 5/9, we are going to get approximately 47.2. And so now that's what we have there. And we've written our inequality for the temperatures in degrees Celsius. So if they ask you to write this out, or what does it mean, it would mean that the temperature in Illinois in degrees Celsius would be somewhere between approximately negative 37.8 degrees Celsius and 47.2 degrees Celsius. So what I'd like you to do now is jump down to the guided practice questions, 9 through 13. Go ahead and do a couple of those. You can pause the video and hit play when you're ready to move on. And here are the answers to the guided practice questions 9 through 13. So we're solving the inequalities, then graphing the solutions. Now notice again, these are all compound inequalities. The first two are and problems, 9 and 10, and the second two, 11 and 12, are or problems. And then when we jump down to 13, you're using the guided practice in your, or that practice problem in your book, which is example 7, and you're solving it the same way as you did there. So here is your assignment for section 1.6. And once again, 1.6 was on solving linear inequalities. So what we're doing is we're taking these inequalities and we're solving them for the variable in question. Very, very similar to what we did in solving equations. The biggest thing is now we're talking maybe about some compound inequalities, and you have to make sure to remember anytime you multiply or divide by a negative number, you must switch that inequality sign around. So here again is the assignment for section 1.6.